Good day and welcome. This presentation explores how content-based language teaching in project-based learning, PBL, can improve STEM outcomes for English language learners, ELLs. We're going to discuss research findings, theoretical foundations, and practical strategies to boost science comprehension for English proficiency in middle school ELLs. Nelson Mandela said, "Education is the most powerful weapon which you can use to change the world." We're looking at mastering science education in middle school. We want to explore how content-based language teaching with PBL impacts ELLs, especially in STEM subjects. This method integrates language instruction with academic content, making it particularly effective for middle school ELLs. This literature review examines the last decade's research in STEM education, content-based learning, and PBL for ELLs. I focus on studies related to interdisciplinary learning and strategies to overcome language barriers. The findings support the effectiveness of this approach, but there's a research gap specifically addressing middle school ELLs in STEM. Before diving into the findings, let's focus on a central question from my research. What impact does project-based learning have on middle school English learners' achievement? This question explores how PBL, combined with content-based language teaching, affects the academic success of middle school ELLs, particularly in STEM, and we're going to look at that through some research. So when we're looking at advancing science understanding in the classroom, we're going to look at the approaches to integrate in STEM education. Becker and Park's meta-analysis shows that combining science, technology, engineering, and mathematics into cohesive lessons improves student outcomes. For ELLs, these methods help students engage with content beyond language barriers. And Capraro's research highlights how PBL in STEM offers hands-on learning, making abstract concepts more relatable for ELLs by providing context and meaning to the language. These approaches bridge the gap between language and learning and content mastery, making STEM education more accessible for ELLs. Carl Sagan said, "Our species needs and deserves a citizenry with minds wide awake and a basic understanding of how the world works." So when we're looking at that, we want to tailor education for every learner. So we're going to explore how to differentiate math instruction for secondary level ELLs. Cardamano stresses the importance of adjusting teaching strategies to address the diverse needs of students, especially those with language barriers. ELLs often struggle with complex math concepts due to the language involved. And Cardamano suggests integrating language support directly into math instruction to make these concepts more accessible. This means tailoring my teaching methods to ensure ELLs understand both the language and the math. Differentiating instruction in STEM, where terminology and abstract concepts can be challenging, is crucial. The key takeaway is that by integrating language support, we can significantly enhance ELL's understanding and performance in STEM. Now let's discuss the theoretical foundation of these strategies. Vygotsky's zone of proximal development, ZPD, is a key. ZPD is the gap between what a learner can do independently and what they can achieve with guidance. Vygotsky is explored by Shabadi, Khatib, Ibadi, highlights scaffolding learning, where students receive just enough support to advance. For ELLs, this support is vital to bridge the gap between their language skills and academic demands. In PBL and CLLIL, which is a version of PBL used in Europe, scaffolding may involve visual aids, breaking down tasks, or peer support to help ELLs engage with the material. Studies by Latif, Supriyatna, and Masari, Marini, and Usman show that STEM-based PBL also fosters creative thinking and problem solving. In summary, the ZPD and PBL offers a strong foundation for effective STEM education for ELLs, integrating language development with critical thinking and creativity. And Albert Einstein said, "We cannot solve our problems the same thinking we used when we created them." With that in mind, here's some of the research support I had. These are references I used for my insights I shared with you today, and they include key studies and theoretical works that support integration of content-based language teaching with PBL and enhance the educational outcomes from ELLs. Among these references is Vygotsky's ZPD, which emphasizes scaffolded learning to help students advance. It's crucial for ELLs in bridging language and academic gaps. George Carlin said, children should be taught to question everything they read and everything they hear. With that, let me take some questions and I might be able to give some answers. So what questions do you have about the research I am working on or the sources I referenced?